Pollution, it's a word we hear all the time, right? But what are we actually talking about when we say it? It's not just one single thing. It's this huge, complex system. So today, we're going to decode that system piece by piece and really figure out how it all works. Let's jump in. So let's start with the big question. What does pollution actually mean? Because when scientists use that word, they're not just talking about, some garbage on the street. They have a really specific definition in mind.
All right, part one. What is pollution? Let's get that fundamental definition locked down first.
Okay, at its very core, pollution isn't just about dirt. It's about change, a harmful, unfavorable alteration to our environment. It's what happens when something new gets introduced that throws the whole natural balance completely out of whack.
And if pollution is the effect, well, the pollutant is the cause. It's the active ingredient, so to speak. And the key here, you really got to catch this, is the phrase harmful concentration. This is so important because it means sometimes a substance is only a problem when there's way too much of it in one place.
So that brings us to part two, the pollutant blueprint. Now that we know what a pollutant is, how do scientists actually sort them out? This blueprint is really key to seeing the bigger picture.
Generally, pollutants get classified in three main ways. First, how they break down, or if they break down at all. Second, where they come from. And third, whether they're even supposed to exist in nature to begin with. Let's break those down. First up, how long does this stuff last? On one hand, you've got biodegradable pollutants, like sewage or food scraps. Nature's own cleanup crew, microbes, can take care of them. But then, you've got the non-biodegradable stuff. This is the stuff that just sticks around. Think plastics, glass, or nasty chemicals like DDT. They were designed to last, and they do, for an incredibly long time. Next, where did it come from? Think of it like this. Primary pollutants are like the raw ingredients, ash or smoke pouring straight out of a smokestack. But secondary pollutants, that's what happens when those raw ingredients get cooked up in the atmosphere. They react with each other and with sunlight to form a whole new toxic soup. A classic example is something called pan, which is a major, nasty part of smog.
And finally, does it even belong in nature? This is basically the difference between too much of a good thing and something that's a total outsider. Carbon dioxide, for example, is natural. We breathe it out. But it becomes a quantitative pollutant when we pump out way too much of it. On the flip side, qualitative pollutants like pesticides and DDT are completely man-made. They simply don't belong in the ecosystem, period.
Okay, part three, an attack on the air. So we have our blueprint for what pollutants are. Now, where do they actually show up and start causing problems? Well, let's start with the very air we breathe. Air pollution is pretty much what it sounds like, way too much foreign stuff floating around in the air. And take a look at the causes. Gases, particulates like ash and smoke. Hey, those should sound familiar. Those are often the primary pollutants we were just talking about, being shot directly into our atmosphere.
Part 4, contaminating water and soil. Of course, pollution isn't just hanging out in the air. It has a massive impact right here on the surface of our planet, getting into our water and our soil.
And just like with the air, water pollution is really any harmful change that makes water unsafe or just unlivable. But how does all that bad stuff get into the water in the first place?
Well, there are basically four main pathways. First, you've got agricultural runoff, where fertilizers and pesticides wash off of farms and into rivers. Then there's direct industrial discharge. Third, there's all the litter, plastics and garbage that travel from land all the way out to sea. And finally, you have pollution from activities that happen right on the ocean, like oil spills. It's a whole journey from source to sea.
Now, moving on to soil. The key word here is degradation. We're not just talking about making the ground dirty. We're talking about fundamentally damaging the soil's ability to grow things and support life. It's about making it less alive. And the causes? Yeah, they're often man-made. Chemical contamination from things like pesticides, there's one of those qualitative pollutants again, herbicides, and heavy metals, can literally strip the soil of its nutrients and just make it useless.
All right, part 5, the invisible threats. So far, we've mostly talked about stuff you can often see or smell or touch, but some of the most widespread forms of pollution are completely invisible.
Take noise pollution. It's not a chemical or a particle, it's just unwanted sound. But that constant drone from traffic, construction, and industry acts as a huge environmental stressor, and it affects both us and wildlife in some really profound ways.
And in a similar way, there's radioactive pollution. Look, there's always a certain amount of radiation in our environment. That's natural. The real problem is when human activities unnaturally spike those levels, creating a dangerous and totally unseen threat.
And this kind of pollution is overwhelmingly a result of our own technology. The main drivers are waste from nuclear fuel and the long-lasting legacy of nuclear weapons testing.
And all of that brings us to our final thought. As we've seen, pollution isn't one single problem. It's this deeply interconnected system of substances, sources, and effects. So the real question isn't just, how do we stop pollution? It's which part of this incredibly complex system needs our attention the most right now.